So using the symbols we learned in the previous video, although restricting ourselves to just these three, we're going to do the comparison for each of these numbers, and then we're supposed to write a sentence describing how each statement will be read aloud. So notice -10 and -15. Now -10 is a larger number than -15. In other words, say this, -15 is a smaller number than -10. So both of those two statements that I've written are exactly the same. I'm going to write the top one as a sentence, and how we'd say it is -10 is less than -15. All right, -100 is definitely less than 50. So again, -100 is less than 50. And the square root of 5, did you know that? The square root of 5 is 5, so the square root of 25 is equal to 5. And we would read that as square root of 5 is equal to 5. Did I say 5? I meant 25. Square root of 25 is equal to 5. Okay, so other things that we tend to do, really in the math world, the algebra world, we have like 5 different representations of algebra, if you will. So we can do numerical measurements with tables and graphical measurements with graphs, and we can do verbal, like we've written up here. This would be a numerical expression, this one, or symbolic expression. This would be like a sentence expression. So this is more or less a graphical representation of these different numbers. So here we have a sentence, a number greater than 3. Well, so one way we represent greater than is an open circle, because 3 is not a number greater than 3. So we put an open circle there, and then we say any number above that is greater than 3. That would be a graphical representation of this statement. Then a number less than -3, again, open circle, because -3 is not less than -3, and any number below that or to the left of that. A number equal to 3, the way we show a value equal to something is a filled in circle. So this is the representation. There's only one number that's equal to 3, and that is 3 itself. All right, this one's a little trickier. A number greater than -2, so open circle, we're going to the right, and less than -1, open circle from here, and less than -1. Here's what might blow your minds. There's an infinite amount of numbers between -2 and -1. Infinite amount. There's also an infinite amount of numbers from 0 to infinity and 0 to -infinity. All right, number 18, a number less than -2. So here's where -2 is. We can't include that, so we put an open circle. Then we draw an arrow to the left of it. And then a number greater than -4. Oops, I got a little carried away there with my line. So it's really only the numbers in between here, like this is what we should have with open circles. Okay, and then finally a number equal to -2, again, filled in circle. Those are graphical representations of those expressions. Okay, so for those of you that have 284s or love Excel, here are directions on how to put the square root into those things. I'll show you Excel, but I'm also going to show you Desmos for finding square roots. So these are a list of perfect squares that are good to have memorized, I suppose. Notice there's a pattern. 1, 2, 3, 4, 5, 6. Square root of 49 is 7. 8. Square root of 81 is 9, 10, 11, 12, 13, 14, and 15. So those are the first 1 through 15 whole numbers. And then we know that the square root of 9 is 3. The square root of 36 is 6. This is where it gets a little more tricky. 144 is 12, and 225 is 15. There's some interesting work with perfect squares is what these are called. Now these are imperfect squares, and we call these radical numbers because this is the exact value. Square root of 11 is the exact value. However, we can get an estimate of it. We can do this just kind of analytically by using our perfect squares. So we know that the square root of 11 is less than the square root of 16, and it's greater than the square root of 9. Those are the two closest perfect squares to 11. So we know that the square root of 11 is a value between 3 and 4. And if you look, 11 is closer to 9 than it is closer to 16. So we'll say this is like 3.21. That's what we're going to guess it is. In Desmos, I'm going to smash all of these at once, and you'll see a better approximation. Okay, so again, 78. We're going to look at what is 78 between. Well, 78 is between 81 and 64. Those are the two perfect squares that trap 78. So then if I take this perfect square, or the square root of 64, I get 8. If I take the square root of 81, I get 9. And let's see, what is 78 closer to? Well, it's 3 units away from 81, and it's 14 units away from 64. So let's call this 8.78. Just guessing here, but I'm doing an educated guess based on what I know of perfect squares and the distance between 78 and the two perfect squares. All right, 2 more. So a square root of 99, well, that's slightly less than the square root of 100. And then the next perfect square is the square root of 81. So this is trapped between those two values. Square root of 81 is 9, square root of 100 is 10. I'm going to call this like 9.976. And then finally, 124. Well, that's just slightly greater than 121 and quite a bit less than 144. But then the square root of 121 is 11. The square root of 144 is 12. So the square root of 24 is between 11 and 12, and it's quite close to 11. So let's call this 11.103. Okay, let's see how good my approximation skills are. We're going to switch to Desmos. Those of you using your phone, there's this little keyboard shortcut down on the corner. And in here, we've got the square root button. It's right next to the pi button. And we'll just type in the square root of 11. And using our calculator, that's approximately 3.31. We're supposed to round to the nearest hundredths, 3.32. This is the hundredths place, this 1. So the number after it is a 6, thus we'd round it to 3.32. Square root of 78, if you have your laptop and you have a keyboard, typing SQRT brings up the square root, so you don't have to use the mouse. Type in 78. I've got 8.83 is what we'd round it to. Here's the hundredths place, the number right after it, and the thousandths place is a 1, so we wouldn't round up. Okay, I typed SQRT again. I'm putting in 99, and that's 9.95 when we round to the nearest hundredth. And finally, the square root of 124. I'll use the pad here, and that's 11.14. So now we can go back and take a look. How close was I? I said 3.21 and 3.32. Yep, I'm a little bit off. 8.78, 8.83. Yeah, you know, if we rounded these to the nearest tenth, I'd be dead on. Here I said 9.976, and this is 9.95. I'm a little bit off. And 11.10, and this 11.14. So not bad, right? I'm kind of proud of myself and my educated guesses.